Generally speaking, any AC circuit is made up of an AC source and load, usually a resistive load, which causes a current to flow. For example, let's say the voltage is 110 volts, and the load is 11 ohms. Ohm's law tells us that the magnitude of the current is V divided by R, or 110 divided by 11, which equals 10 amps. The power consumption can now be calculated three ways. Voltage times the current, 10 times 110, or 1100 watts. A second way is to take the current squared, times the resistance, or 100 times 11, which is 1100 watts. The third and final way is to square the voltage, and divide by the resistance, which is 12,100 divided by 11, or 1100 watts. So far we have been dealing only with resistive loads, which work the same for DC as well as AC power. However, there are three major types of linear loads: resistors, inductors, and capacitors. When dealing with capacitive and inductive loads, we have to be aware of the phase shift of the current that is introduced. Without going into details, when dealing with these type of loads, we have to look at the load as impedance, which will shift the current from the voltage, depending on the type of impedance, capacitive or inductive. Also, we have to be certain that we are using RMS values for these loads, current, and voltage. In most cases we are not concerned about the phase shift when doing low voltage wiring, however we should be aware that this exists. In order to understand some of the wiring techniques, we should first have a peek inside the main breaker panel. Power from the utility enters in the form of two hot wires, and one neutral, arriving into the breaker panel. The neutral is connected to a neutral bus bar. This bus bar contains several screws that can receive outgoing neutral connections. One of the hot connections is connected to a hot bus bar, let's call it A. The voltage of this bus bar is 120 volts RMS, with respect to the neutral. The outgoing current limiting devices, breakers, are connected here. The other hot connection is connected to a second hot bus bar, let's call it B. The voltage of this bus bar is also 120 volts RMS with respect to the neutral. The case of the main breaker panel is grounded, and these ground connections are connected to a ground bus bar. This bus bar contains several screws that can receive outgoing ground connections. Inside this breaker panel, the ground bus bar is connected to the neutral bus bar. This is called bonding. Bonding is the process of joining metal enclosures, equipment, raceways, metal water piping, gas piping, structural steel, and the like, together. Bonding items together, and connecting the bonded items to an equipment grounding conductor, places everything at the same potential. In this case, the neutral, and ensures an effective ground fault current path, in the event of a ground fault occurring in an electrical system circuit. A bonding bar ensures that the neutral is at ground potential. And lastly, there are two metal tracks that will hold one end of the breaker, the other end snaps and connects to the hot bus bar. Stay tuned to this site. The next nugget that I release will be a continuation of this video, where I will be diving into more detail of the essential rules. In the meantime, as a bonus and in the way of a thank you for your continued interest, I'm making available my 50-page electrical power crib sheets, if you haven't already taken advantage of downloading them. These were prepared for use with my courses. There is one section associated with each course, and are extremely valuable while viewing the course, as well as a recall of the pertinent formulas and information after the fact. The contained information is also useful during any technical career as a quick reference from time to time. Simply fill out the information requested when you go to this website. https://bit.ly/47y_3 and lastly h. As I said in the beginning, stay tuned for future releases on this site that will provide you with more tantalizing nuggets of what is available in my courses. You can also directly access my StanStore courses at this website. https://stan.store/G V B